Hello everyone and welcome back! In the last couple of lessons we have introduced hashing and salting and dictionary attacks. What we're going to do now is we are going to choose one particular hash function and we are going to use it in our service. We are going to use it to store passwords in our in-memory database. So the question here is, which hashing function should we use in our implementation? Because so far we have been using this hashing function here, but this was just for demonstration purposes. So how can we choose one? Well, what is recommended is, depending on when you watch this course, to head over, for example, to the OWASP website. So OWASP is the Open Web Application Security Project. So this is a not-for-profit organization that gives a lot of guidelines of how to secure web applications in general. So looking for the password storage recommendations, we're going to see here some recommendations for what hashes to use. So this list is continuously updated. There are continuous competitions, international competitions for finding the best hashing function. And also old hashing functions are considered deprecated. So for example, a very ancient hashing function was called MD5. We should not use that for the purposes of password storage. So we can see here that Argon 2, this is the name of a hashing function, it's the winner of the password hashing competition and should be considered our first choice for new applications. So we are going to follow here the OWASP recommendation and we are going to be using this in our implementation. Make sure to check this list to see if there is not another function that is now recommended. As you can see, password-based key derivation functions that we were using in our previous example are also okay. They come here at number 2. They are available in the Node crypto module, which is built in. So many times this is needed for certain types of certifications for your system. So make sure to take those constraints also into account. For the purpose of this course, we are going to be looking for an Argon 2 implementation for Node. So we will be using this library here, the Node Argon 2 package. So this is a package that clearly has here some good social proof. Also, it has a very simple API, meaning that it's very easy to use this package correctly and it's hard to use it incorrectly, meaning that this package would be superior to other packages with a more complex API. Let's see why. As you can see, in order to create a password digest, we just pass in the password and we get back here a hash. And you might be thinking at this point, the salt seems to be missing. We should be generating the salt and passing it here as a second argument. Well, actually, as we can see here, the salt is being generated internally by the library itself. And of course, it's being appended somehow to the output of the hash so that the next time that we try to verify a password, we still have the unique per user salt. So this means that this API, although very simple, it's actually superior to a package that, for example, would use an API where we pass a second argument, the salt, because we could pass a plain numeric value to the salt. Maybe the salt did not have enough random digits. So this way we are protected against all those situations where we are misusing the hashing function. This package makes it easy to use the hashing function correctly, and that's what we are looking for. So let's install this in our system. We are simply going to head over here to the terminal with Alt F12 and we are going to install the package. We are simply going to do npm install argon2, which is the name of the package. So with this new package in place, let's now use it here in the create user routes. So we will no longer be storing the password directly. Instead, let's quickly rename here our DB user. This is going to be the password digest instead. So let's hit Shift F6 and let's refactor this. This will replace password by password digest everywhere in the program. Now let's go back here to the creation of the user. And let's also here rename this variable. So this is no longer the password. This is going to be the password digest. So going back here to the create user route, what we're going to do here first is we are going to use Argon to create the password digest and then we're going to save it. Let's then refactor this implementation. So we are going to be using Argon 2 to hash the password first. That's the first thing that we are going to do. We are going to pass into the hashing function, we are going to pass in the password. So this is going to return a promise. And here at the result of the promise, we are going to be receiving here as the first argument, we are going to be receiving the password digest. Let's then take this code and we're going to paste it in here in the then block. So to the create user function, we are going to be passing the password digest this time around. And here inside the then block, we are going to send back the response to the browser. So let's now try out this implementation of create user. There is still one last problem with it, even though we are using the hashing function. Let's have a look. We're going to refresh the sign up screen and let's open here the console and let's also put in here the server running. Now let's try out the screen. We are going to use here a test email and let's take precisely one of the most common used passwords. So the most common password probably in the world. We are going to use it here as the password. We are going to confirm this and notice here the server. We are going to click sign up. So everything is working as expected. And now we are storing on the password a password digest, an Argon 2 password digest. The problem here is that there is no password policy in place. So this type of passwords, such as for example all numbers, this is still accepted by our system. So we need to put a password policy in place. We'll have a look at that in a moment. Right now, let's create here a second user. We're going to put the email test2 and to this user we are going to pass the same password. So we just want to confirm that indeed these two users will have different digests. So if we hit sign up, we're going to have here a new result, a new digest for each of the users. So as you can see, the digest is indeed different even though the password is the same. Now you might be wondering where the salt is. So the salt is embedded here inside the password digest. It's somewhere here with a predefined length that the library already knows. So as we can see, if somebody would steal the database and would become in possession of the digests, they would immediately know this is an Argon 2 digest. It has these input parameters. The salt is also embedded here. So this is why using a password policy is essential in combination with using a function such as, for example, Argon 2. So using a password policy is really the last piece of the puzzle in terms of best practices of password storage. Let's then add a password policy to our application. This is coming right up in the next lesson.